A-level statistics. Looking at averages, the mode and the median. Let's consider the mode and the modal class. If we have a discrete set of data, the mode is the number that appears most often in the set. For example, find the mode of each of the following data sets. Now in the first set, if we sort the list in order, we get 3, 3, 4, 4, 5, 5, 5, 5, 6, 7. We see that 5 is the most frequent number in the list, and so the mode is equal to 5. In the second list, if we put it in order, we get 2, 2, 3, 4, 4, 4, 5, 5, 6, 7, 7, 7. And we see that both 4 and 7 appear 3 times. Now there are 2 modes for this set, and the set is called bimodal. The modes are 4 and 7. In set 3, if we put the numbers in order, we get the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9. In this case, each number only appears once. So there is no mode for all the numbers, as all the numbers appear equally many times. And so our answer is there's no mode. Now in the next example, put 45 numbers in a stem and leaf diagram and find the modal stem. Well, to solve this, we notice that the lowest numbers are in the 20s and the highest numbers are in the 70s. So we can create a diagram going with stems from 2 to 7. Then we can fill in the leaves, and we can instantly see that stem 6 has the modal group. It is the longest set of leaves. Now let's consider continuous data. If we have continuous data, it's unlikely that we'll have many numbers repeating exactly. This means we'll need to group the data. Now the modal group is the group with the highest frequency density. So let's look at an example. We're given a list of numbers and we're asked to group it into the following sets. From 20 up to but not including 30, 30 up to but not including 35, 35 to 40, 40 to 45, 45 to 55 and 55 to 70. We're asked to find the modal group. Now we can count how many elements there are in each group, and that gives the following table. The frequencies are 6, 6, 16, 11, 11 and 10. Now the group sizes or class sizes are the difference between the upper and lower bounds of each group. So we have class sizes of 30 minus 20, which is 10, 35 minus 30, which is 5, 40 minus 35, which is 5, 45 minus 40, which is 5, 55 minus 45, which is 10, and 70 minus 55, which is 15. Now we can work out the bar heights. The bar heights are equal to the frequency divided by the group size. So they are 6 divided by 10, 0.6, 6 divided by 5, 1.2, 16 divided by 5, 3.2, 11 divided by 5, 2.2, 11 divided by 10, 1.1, and 10 divided by 15, 0.67. We can then draw this in a histogram. We see that the modal group is the group 35 to 40. If we look back at the raw data, the only repeats are 39.8, which repeats 3 times, and 44.9, which is twice. If the data was measured more accurately, it's unlikely there would be any repeats, so we would not find any modal number in the data. That's why we put it in groups. Now let's have a look at the median. If we have a set of values that have been listed in order of size, then the median is the value of the middle term. If there are 2 middle terms, then the median is the mean of those 2 terms. For example, the median of the numbers 3, 5, 9, 11 and 15 is 9. We can clearly see that's in the middle. The median of the numbers 2, 5, 6, 9, 10, 13, 19 and 20 is the mean of 9 and 10. 9 and 10 are the two middle numbers. So the median is 9 plus 10 over 2, which is 9.5. Let's have a look at an example. In the stem and leaf diagram, find the median. Well, to solve this, there are 45 numbers on the stem and leaf diagram. So we want the term which is 45 plus 1 over 2, which is the 23rd term. So if we count through the leaves from the top, we find this gives us 58. So the median is 58. Note, if we have a list of values, then to find the median we must remember to place them in order of size. If we have a list of n ordered numbers, then the median term is the n plus 1 over 2th term. If n is an even number, then the median is the mean of the n over 2th term and the n over 2 plus 1th term. Let's have a look at the median of some grouped continuous data. If we want to estimate the median of a grouped set of continuous data, it's a good idea to draw a cumulative frequency graph. For example, find the median of the data shown in the following table. Now to solve this, we need one more column in the table for the cumulative frequency. Now these are 5 plus 17, which is 22, 22 plus 24, which is 46, 46 plus 25, which is 71, 71 plus 11, which is 82, 82 plus 6, which is 88, 88 plus 5, which is 93, and 93 plus 7, which is 100. We can now draw out a graph grid. It's a good idea to circle the first group boundary with a circle. This reminds us to mark the point 0, 0. So we can then mark all the points. Now they are 0, 0, 10, 5, 20, 22, 30, 46, 40, 71, 50, 82, 60, 88, 70, 93, and 80, 100. We can then join with a curve or straight lines. Now to find the median, if we go halfway up the y-axis, then half of the data is below and half of the data is above this point. So if we look across to the graph and then down to the median, we find the median is 31.5. So we've seen there are three types of average: the mean, the mode and the median. And we have to choose an appropriate average. If we have a set of data, the mean, the mode and the median may each have quite different values. It's important to decide which is the most appropriate. Let's have a look at some examples. Suppose the mean age of people at a party is 16. This suggests a party for teenagers. However, the ages could be 3, 3, 3, 4, 4, 4, 4, 4, 5, 5, 75 and 78. It is in fact a party for small children run by their grandparents. The mean is not appropriate here to describe the event. The mode, which is 4, would be much better as it suggests the party is for small children. If a class is given a test out of 20, it's quite possible a number of pupils might get full marks, while the rest are spread between 0 and 19. The mode is then quite likely to be 20. However, this is not a very appropriate average, as nobody gets above it. The median would be a better average, as half the class gets above it and half gets below it. Thus each person can see if they're in the upper or the lower half of the class. When considering salaries for employees in a firm, the mean might be the most appropriate average. By multiplying the mean by the number of employees, we can find the total salary bill. Also, if everyone gets a pay rise of R%, then the average increases by R% also. So we've seen that in different situations, different types of averages might be more appropriate. So a good selection is important.